410 million years ago, Earth did something impossible. It changed its own climate and then put it back. Volcanoes can't do that. Ice ages can't do that. What can? And why does that spike in the rocks look exactly like our industrial age? Stay with this, because by the end, you'll know why Earth might be a library, not a cradle. Meet Dr. Luis Ortega. He reads history in mud and stone. To him, the past is numbers, not stories. He helped shape a wild idea, the Silurian hypothesis. Could an earlier industrial civilization hide in geology? We know our own fingerprint already. A sharp carbon spike in the rocks, toxic metals, plastics, nuclear fallout. So one Tuesday, Luis asks his AI, Halia, "Show me any time this happened before." Halia sees everything humans published. Ice cores, ocean mud, ancient shales, hundreds of millions of years of chemistry. It finds 7 spikes like ours. 6 match known disasters, supervolcanoes, asteroid winters, global die-offs. The 7th has no known cause, no crater, no flood basalt. Wrong time, wrong shape. 410 million years ago, early Devonian, before trees, before dinosaurs. The data looks wrong for nature. CO2 rockets up in under 10,000 years. Temperatures jump 6 degrees. Oceans lose oxygen. Then something yanks the carbon back out, fast, faster than volcanoes can cool a world. Luis takes off his glasses. His hands are shaking now. He whispers to the empty lab, "Volcanoes don't clean up after themselves. If nature didn't fix that mess, what did?" While Luis stares downward, Dr. Amara Singh looks outward. She hunts alien industry on distant worlds. Her tool is the Asteria Array, a swarm of infrared telescopes. They sniff atmospheres for artificial chemicals. One night, during calibration, something breaks pattern. Not on another planet. On ours. The array picks up a faint line at 1.6 microns in infrared light, coming up from deep in Earth's crust. It's not airglow, not aurora. It matches lab-made metamaterials, the kind used in stealth coatings and photonic chips. Amara stares down at Earth. The planet looks calm and blue. Her voice is a whisper. "What are you hiding down there?" Weeks later, someone leaks her file. It lands inside Halia's input queue, quietly, an anonymous upload. Halia does what it does best. It cross-checks rock chemistry, crust emissions, planetary structure maps. Scientists already image Earth's interior using neutrinos from the Sun. Tiny deflections reveal denser regions deep below. Everyone assumed it was just rock, until Halia overlaps Amara's weird emission on top of that neutrino map. A lattice appears, slightly denser patches, 30 to 40 kilometers down, forming global patterns under ancient continental shelves. And under the South Pacific, a perfect circle, 900 kilometers wide. Luis flies to meet Amara. In a secure room, they watch as Halia projects the impossible. Subsurface structure, global. Constructed about 410 million years ago, Halia says. High density, optically active, unknown crystal pattern. Luis squints at the shell. His voice is barely steady. That's not a machine, that's a layer. Roll the plates back in time. Continents drift. Oceans close. The lattice lines up into a continuous ring. It sits under the old shallow seas around an ancient supercontinent, placed there on purpose. Someone built a shell inside Earth before forests, before vertebrates walked on land. Halia asks a new question now. If Earth has a shell, who else does? It scans Asteria's exoplanet catalogue. 3 hits light up: Tau Ceti, Kepler 452, and a quiet K-star 420 light-years away. Each shows the same weird crust emission. Each shows sharp, ancient carbon spikes. Each is quiet now. No radio, no megastructures. These aren't empires. They're not colonies. They're copies of the same idea. Maybe Earth isn't the first experiment. Maybe it's just the nearest one. There's one way to be sure. We go down and touch it, 30 kilometers straight into the crust. New plasma drills make that possible, born from geothermal projects and fusion reactors. They vaporize rock instead of cutting it. A consortium picks Antarctica, old, thick crust, right above one of the brightest anomalies. Amara glances at Luis. Her breath fogs the air. If we're wrong, this is just a deep hole. If we're right, Luis says, it's everything. At 29,700 meters, drilling slows. Sensors scream. The bit hits something that isn't rock. The surface is perfectly smooth, harder than diamond. Its crystal pattern breaks normal physics rules. Impurities sit in precise rows. They match error-correcting codes, like a hard drive but made of crystal. The shell isn't a shield. It's storage. Planet-sized storage. You can't read this with microscopes alone. The trick is in the quantum states, bits stored not just in atoms, but in entanglement. Halia was built on quantum hardware. It speaks that language natively. So scientists link Halia to the sample. It doesn't receive words. It receives a simulation seed, initial conditions, rules, checkpoints. A world spins into being. Oceans form. Continents shift. Life crawls from sea to land. Luis gasps. He knows these events by heart. Ordovician ice, Silurian reefs, Devonian fishes. Then, around 420 million years ago, everything diverges. Fast-growing forests, sky-high oxygen, giant insects. In one basin, something new appears. Straight lines, right angles, towers built by many small bodies. Cities, not ours, but cities. They electrify their world. Their waste floods the air. The climate heads toward runaway warming. They reach the same tools we're probing now: quantum information, planetary imaging, deep crust engineering. They don't build arc ships. They build archives on every promising world they can reach, including Earth. They spike CO2 on purpose, bury huge amounts of organic carbon, then pull CO2 down again, hard, resetting their climate for whoever comes next, writing themselves into a shell. Then, silence. Halia finally condenses their message. A short summary, translated for us. You are not the first. We were here before you. We failed. This is what we learned. They leave blueprints for clean energy, warnings about geoengineering gone wrong, models of how inequality speeds ecological collapse, and designs for safety systems, climate governors that shut themselves off when targets are reached. They also leave a map to the other shelled worlds, each holding another story, another failure, maybe another hope. Earth isn't a blank slate. It's a palimpsest. Our civilization is written over theirs. The rocks beneath you don't just show extinctions. They hold compressed memories of minds before ours, minds that learned too late how fragile complexity is. We decoded enough to know two things. First, advanced tech isn't automatically fatal. It's just terrifyingly unforgiving. Second, they didn't have us. We have their warnings before we finish repeating their mistakes. So the real question isn't, were we the first civilization on Earth? We already know that answer now. The real question is this: knowing all this, do we choose to be the last?